thank you very much for taking the time to call into our camps today. We have Dundas with us live. Dundas can give a wave. Hi, Dundas. And we have our camp also in Tillsonburg as well. So Tillsonburg can give a wave there. Hi.
Hi, guys.
All right. So as I was saying, this is Jamie McIntyre, and he's a professor at the School of Mechanical and Engineering Technologies at George Brown College. So he's going to be telling us a little bit more about what he does at that school and specifically with robotics. So really looking forward to that. So hello and welcome, Jamie, today. And also we have our camps across Ontario. We have 9 other camps watching a live stream of this, and they're going to be submitting questions on Twitter. In fact, some are already coming in, so I think we'll have a really good question and answer session.
Okay.
So hello to everyone watching the live stream as well. So as I said, today's Robot Day, and the campers are going to be learning all about robots and how they work, and they're going to be building a battery-powered robot and a solar-powered robot as well. But first, Jamie, I'll hand it over to you. Can you tell us a little bit more about what you do at the School of Mechanical and Engineering Technologies, and maybe specifically what you've done with robotics?
Sure. So what I do, I have a couple of slides that I'll try to share with you here that talk a little bit about what I do at the college and show you some of the cool stuff that we've built here with our students. So if you hang on for just a second, I'll see if I can get this going here. Right. Oops. You see that okay?
To me, it's appearing mostly black with some white sort of squares and pixels. Is that how it starts?
No.
Oh, it's loading. It's slowly coming through. It might just be a delay in the video.
Okay.
Oh, actually, there we go. I can see that slide now.
Okay.
Can everyone else?
Yeah. Oh, okay. I hope you can see that okay. Okay. Get back on here. Sorry, I'm just struggling to get you back here. Okay, so I guess you can see what I'm seeing here. So first of all, my name's Jamie McIntyre, and I'm a faculty here at the college, and I also coordinate the mechanical programs. I also do a lot of research, so we have a lot of companies and universities and hospitals who come to the college looking for help making things, which is kind of my specialty here. Here at the college, lots of people are interested about college versus university and what the difference is. Here at college, we kind of focus more on the hands-on stuff, as opposed to universities can be a little bit more theoretical. So if you want to be an engineer, you can go to university for 4 years, or you can take another stream and go to college, and you can see that we do things like mechanical engineering, electromechanical, and we do a lot of machining as well. So a lot of people actually end up doing both, and they'll either come to us for a couple of years and then go on to university. And we also get people from university that come here to learn some of those hands-on skills.
Cool.
Can you hear me okay?
Yeah.
Oh, great. So this picture shows kind of what our school kind of looks like. And in the top corner, you can see that we still have big machine shops here. We do a lot of, spend a lot of time teaching our students how to run equipment safely and how to teach them the skills to be able to fabricate different sorts of things. In the next picture, this is kind of our hacker space. So this is where our students get in there and try to dream up all these crazy things to build. And I'll talk about some of these projects in just a minute here. And in the bottom slide, or the bottom photo, there's a picture of some of the prototyping equipment you use. And this particular one is something called a water jet cutter, so that we can design stuff in software and then go in and cut it out of metal using a high pressure stream of water and sand. And we can fabricate mechanical parts or metal or things like that really, really quickly, which is really important for us. Sorry. So kind of what we do here, we do a lot of mechanical design, so parts of robots that are mechanical. We also do a lot of electronics here as well. So we design circuit boards, we lay out and test circuits and that sort of thing. Of course, if you're building robots, a lot of it is about writing software, and you have to be really good at writing software to do that. So we teach our students how to do that as well. And then the last thing we do is what we call rapid prototyping. So the water jet's kind of an example of that, but also things like 3D printing. We do a lot of 3D printing here to make parts in a hurry. Our kind of mantra I wrote at the bottom is that we can make anything. That's what we try to do. We try to preach here at George Brown College, so that any kind of crazy inventor that comes here with an idea, we're the ones that know how to make stuff. So what I'll do is now I'll show you a couple of examples of some of the things that we've made in the past. The first one here is an example of a crane that we built for a company here in Toronto that builds large construction cranes, and they wanted a small one that they could wheel in and out of elevators. So this is an example of a model that we came up with that was designed in a SolidWorks is the package that we use. And we actually fabricated this out of steel and gave it to the customer, who's now tweaking it a little bit, and he'll make these and sell these here in Ontario. One of the other projects that we built a few years back was we built an electric race car. So the students would start with just a piece of paper, designing what the car would look like, and they'll design all the parts in software, and then they'll build it all from scratch. And so we built this electric race car, and they actually broke the speed record at Road America in Wisconsin with this car.
Wow.
We build lots of fun stuff. This was a pinball machine that we built. And of course, pinball machines, if you ever open one up and look inside of them, there's all kinds of really great mechanical and electrical parts in there. So one of our tasks for these students was to build a pinball machine that we could actually play. And we keep this in the lab for fun sometimes. Now, I understand that you campers are interested in robots, so I have a couple of examples of some of the robots and related things that we've built. So this crazy thing is probably the most complicated robot that we've ever built. And what this is for a doctor downtown, Dr. Tina Masami, and she is what's called a maxillofacial surgeon. So if something bad happens and you get in a car accident and say your face gets damaged, Tina's the surgeon who's going to go in there and make those corrections. And one of the things she has to do sometimes is operate on people's jawbones. So she'll go in and cut through your jawbone. Oh, this sounds a little bit gross, I know, but she'll cut through your jawbone and then line it up and then bolt it back into place, just like that. And what we built here was a robot that helps her align jawbones so that she can make a fixture to hold them in place while they heal. So this was quite a complicated robot that we built. And you can see what's special about it is there's actually 6 of these arms, and by controlling these, what we're able to do is move it in 3 directions, in X, Y, Z, plus we can rotate it in any one of those directions as well. And in fact, this robot, we kind of got the idea by looking at the way that they build flight simulators. It's really the same thing. The robot's controlled by a what's called an Arduino, a little microprocessor. And of course, there's a big power supply in here to keep things moving as well. So my students designed this from scratch, and they would have made all these mechanical pieces and then put it together to make it work. Now, the hardest part about this particular robot wasn't the mechanical parts, and it wasn't the electronics. The hardest part about this robot was the math. So if you're going to build a robot that's going to move very precisely, we had to figure out using equations, well, if I move one of these arms by a little bit, how does that move the upper jaw here, so that we could move it in the X, Y, and Z and rotate it in a very controlled fashion. So the longest part was actually with a pencil and paper trying to figure out the math of this.
Wow. So, Jamie, can I just jump in with a question from one of our camps on Twitter? So you're talking about all these different robots and, all the different things that you can have a robot do. Brantford wants to know, is it possible to program a robot to do whatever you want? Like, are there any limits on what you could get a robot to do?
Well, it all depends on the complexity. Are there any limits? Well, I wouldn't say there's ever any limits, but certainly, the technology of today limits you in certain ways. One of the most difficult parts about doing robots is actually the environments that they're going to be in. So, for instance, lots of people think when first thing they think about robots is they think about ones that are inside your house, and your house is actually a really complex environment. So a robot that would move around for floor, for instance, well, you have to worry about things like carpets, and you have to worry about things like different kinds of floors and the stairs and the walls, and it's actually a pretty complicated environment. So in terms of limitation, you're really limited by your own kind of imagination as to how complex you can make the software to run the thing. There's all kinds of sensors that you can add to it. But it's just your limits your imagination as to what you can build.
Oh, very cool. So the campers can certainly get creative today. Maybe I'll go to a question from one of our live camps. Is there a question in Dundas for Jamie today about robots? Just need to come up to the mic. Okay.
We have a question here in Dundas, if that's all right.
Yeah, go ahead, Dundas.
Can robots have feelings?
Woo, that's a complicated one. Lots of people are trying to create machines that work or can think in the same way that people do. And there's something very famous that you might have heard of. There was a very famous guy. In fact, he invented one of the first computers during World War II, and his name was Dr. Alan Turing. And he created a test that said that if you could speak with a robot or a computer, let's say that you had a phone call with a computer, and if it could trick you into thinking that it was a real person, then that would be a sign that they've actually created artificial intelligence. And he kind of thought about this back in 1940, and just recently it's been in the news that somebody thinks they've passed the Turing test, so that robots will behave, or computers will behave and act just like kind of people do. Will they ever have feelings? I don't think so. I think they'll be able to interact with you, and you would almost think it's a real person. But I don't think they're ever going to be able to kind of feel the same kind of things that you and I do.
And maybe that's a good thing. I don't know.
I think so.
Yeah.
You don't want them to get angry.
No. How about in Tilsonburg today? Was there a question we could go to for Jamie about robots?
You know those robots that clean your floors? How do they know where to clean without going on a carpet or bumping into anything?
Oh, so yeah, I mean that's kind of the most famous robot probably is the Roomba, right? The one that follows along your floor and cleans your carpets. Um, Again, I always think back of the old days, and back in the 1940s and the 1950s, they used to think that we'd have robots doing all kinds of things inside your house and lifting you out of bed and making dinner for you and that sort of thing. And of course, none of those really showed up yet. But the Roomba is here, and it will clean your floors. So how the Roomba kind of works is it uses ultrasonic sensors that bounce sound wave off your walls so it can tell when it's approaching a solid thing, and it just knows to turn. So it follows kind of a random path, which is actually a little bit easier. We don't have to worry so much about where the walls are and how big your room is. The logic in that robot is very, very simple. It just says, if I see a wall, turn. The other thing with robots like that is you can set up little sensors near places where you don't want them to go. So for instance, if the Roomba's headed towards the top of your stairs and it could head over the edge, we can put a little pylon there that says, don't come over here, it's not safe. And as your robot approaches, it'll just turn away. So people look at the Roomba as, I mean, it's a good example of a robot because lots of people say, well, are robots smart? And the ones we have today are really not so smart because all that robot really knows to do is, if I see a wall, turn.
Yeah. So kind of simple robots
Very
in the house. I have another question on Twitter from our camp in Paris. Hello, Paris. Thanks for your question. They want to know, like, I guess, say you're building a robot or designing a robot, what is the most important feature of a robot?
Well, you know, when I'm teaching my students how to design things like that, one of the first things we really try to make them think about is the environment that the robot's going to be in. So, for instance, mentioned even trying to vacuum your floor is a tricky kind of activity because there's all kinds of irregularities that can mess a robot up. So that's the first kind of real important part. And wherever your robot's going to go, it's really critical to understand that really well. So the second thing, when you're actually looking at the robots themselves, there's really kind of three aspects to what make a robot, at least in the way that we think of them here. And of course, the first thing is about how does the robot move. So robots usually have some kind of motor or some kind of mechanism that's going to make the robot move and actually do something. The second big aspect is how the robots kind of sense. So there's all kinds of different sensors depending on what you run your robot to do. In the case of the Roomba, I mentioned there's something called an ultrasonic sensor. So it will bounce a sound wave off something and then look at the reflection that comes back. But you can also look at things like light. You can look at things like temperature. You can look at really simple things just like switches. So if a robot bangs into something, it closes a switch, and then we can do something based on that. The third part, which is probably the most important of those three, is kind of the idea about feedback. So that with your robot, it moves, it senses something, and then what do we want it to do afterwards? So if I hit a wall, I want to turn. If I'm not going in a straight line, I want to correct, something like that. So robots will move. We have to think about that. Robots will sense. We have to think about how we want them to sense. And then this idea about feedback. So what do we do with what the robot sees and feels as it moves around?
Okay. So lots of different aspects interplaying, and obviously robots are computers. Is that sort of, they're computers that move? Like,
Most of them are computer control. So again, that kind of feedback part, that's really where we need to be able to kind of write software in order to make those kinds of decisions. If I see this, do this. If I see this, do something else. And so that's probably the as you get more advanced. Now you can build very, very simple ones just with switches that can't really think. They just kind of react to whatever it is that happens to them. So for instance, some of those little toys that you buy that bounce off of walls, those are examples of ones that really don't have any thinking to them or any decision making. They just react, bounce, turn, bounce, turn.
Okay. Was there another question in Tilsonburg? I thought I saw maybe somebody's hand up there. Another question for Jamie?
Good question.
How can robots move?
Tilsonburg, your video's off.
Oops. Oops.
That's better. Hi.
How can robots move?
So the question is, how can robots move? Well, most often what we do is we'll put motors into them. So we can put electric motors is probably the most common way that can turn wheels or can turn arms or make that sort of thing. And so what we do is we have to have some kind of a power supply. So if you can still see my slide on the screen here, with this motor, you can see this big box in here. All that's doing is just supplying power to be able to move the robot itself. And that's often the time when we're designing robots, that's a big problem, is how are we going to get power to it? And the most common way to do it is with using batteries or that kind of thing, because you want it to be able to move around without wires. So electric motors is really common. And again, we kind of control these things with software so that we can make them move slowly or make them move fastly, or very quickly, I should say. And of course, make them stop and start when we want to.
Okay, it looks like someone else in Tilsonburg really wants to ask a question, so I'll go to them one more time.
How do you make robots go upstairs?
Whoa, that's a tricky one. We haven't built a robot to climb stairs, though we've had a couple of people tossing around ideas. Not so much a robot per se, but an assistive device for people that are in wheelchairs. So you can imagine if you're confined to a wheelchair, a set of stairs is a big problem for you. So to come up with a system that's able to put a wheelchair in and then lift them up. The mechanisms would be quite complicated, especially if you can't really attach yourself to the chair. Attach yourself to the stairs. Yeah, I'd have to think about that one. That's a good design problem to be able to climb. One of the neatest kind of designs like that we've seen is a robot that's actually inside a ball, and it was about the size of a soccer ball. And by turning the motors inside of it, you could have it roll around. So I know that robot would go down the stairs pretty well, but it would have a hard time getting up them.
Good question in Tilsonburg. So I see a question in Dundas right now. So Dundas, what's your question?
All right, my buddy Zach has a question here.
What was the first robot and what did it do?
Ooh, I'm not sure I know where the first one kind of came from. The thing about, if you look back, most of the first robots that were out there were fake. In fact, lots of you go back to watch old movies and things and about the robots that come and take over the world. They're really just empty boxes with people inside of them. And if many of you guys have seen the movie Star Wars, of course, I think everybody's seen Star Wars. And the little robot R2-D2, there was actually a guy inside that making that robot move because it was too complicated at the time when that movie was made to actually build a robot that would think and react the way that one did. And of course, C-3PO, the other robot in that movie, there was a guy inside that suit as well. That must have been a hard job being in that suit all day making the movie, I would think. But again, they kind of faked those early robots. probably the first real, the real home of robots is if you go to a manufacturing plant. So, for instance, if you go to where General Motors or Ford makes cars, they've got tons of robots in those factories, welding bodies together and putting windshields in and doing that kind of thing in cars. So the first kind of real useful robots would have showed up in factories. And the reason robots work so well in factories is that they just do the same thing over and over and over again. The kinds of jobs that people don't want to do, but robots are really, really good for that. They don't get tired and they don't get sick, and they'll just work all day long. So the big advantage to have those in a factory. But I think the first real robots that were of real value to people would have showed up in manufacturing plants.
Good question from Dundas. So we're coming to an end for our time with Jamie today, but I do want to go to one more question on Twitter from Brantford. They want to know, what is the smallest robot?
What's the smallest robot?
And what might a smallest robot be used for?
Well, there's probably the smallest robots, at least one area I know that there's some research going in, is actually in operating rooms. So when they're trying to do surgery on people, one of the things they try to do is do surgery using the smallest kind of incision that you can make into somebody, because you heal a lot faster, less likely to get sick. So some of the smallest robots that they're developing are used in medical applications. So what they might do is make a small cut in a patient, and then with a small robot that could go inside that the doctor can control from the outside using cameras and motors to move around and that kind of thing, and then actually operate on somebody without actually having to open a person right up and put your hands inside of them. I know that sounds kind of gross, but that's what doctors do. And those are probably some of the smallest ones that are out there right now that I know of.
Wow, very cool. Well, thank you very much, Jamie, for taking the time to call into our camps and answer all our campers' really great questions about robots. I hope they learned as much about robots as I think I did today, so thank you very much. And thank you for our live camps as well, Dundas and Tilsonburg.
Okay, thanks.
Thank you.
Bye.
Bye.